Okay, so this test next class, class 9 physics, okay? Chapter 11, work and energy. So 11B will cover these questions. Now in this portion of the test, primarily it will cover two formulas. That is your kinetic energy, the half mv square. That is the energy possessed by a body due to its motion or moving body. And the next formula is the potential energy formula. EP is EP. Usually your textbook is denoting it by EP, I think. Yeah, so EP is equal to mgh, energy possessed by an object due to its position above the ground. Okay, so keep those two formulas. Primarily that will be more than enough, I think. So let us start with the first one. Example 11.4. This you'll find on page 162, I believe. Yes, so let me read the question. Go to page 162. Example 11.4. What is the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass of the car is 1500 kg? So as we read the question, when the first car first appeared, it was having a velocity of 30 km per hour. So that it will be the initial velocity, because the first one that appears is the initial velocity. Now we need to change this to SI unit, and we know for length or distance is kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. So this is the conversion factor for conversion of units for length. Okay, the factor is 10. So here, since the SI unit of distance is meter, kilometer has to be changed to meter. This means changing a bigger to smaller unit, moving 1, 2, and 3. So write the original number, and each movement is 10, another movement 2 and 3, so 3 zeros, and therefore kilometer will disappear and meter will come in. Divided by, now for time we know this factor is quite easy, hour, minute, and second, and we know that 1 hour is 60 minutes and 1 minute is 60 seconds. So you're changing hour to minute means shifting two places from big to small, 1, 2. Nothing is in the denominator means it's 1 hour, right? So big to small, so multiply by 1 place and 2 places, so 16 to 60, and hour to the power minus 1 will therefore is now converted to second to the power minus 1. So that's how we change the kilometer per hour to the SI unit, meter per second. Just go about it slowly. The 2 zeros can cancel, as we can see, and then 6 ones are 6, 5s are 30, 0, 2 3s are 6, and here 2 2s are 4, 1 in hand, 5s are 10. So here 25 by 3 meter per second. So this is the initial velocity of the car as it appeared in the question. The first one is the initial velocity. Increased to 60 means there's a final velocity. So final velocity is usually denoted by V. So 60, likewise, you can just write here similarly and cut this step. 60 km per hour directly change to 000, then meter per second means here 1 into, we are doing directly because we can put here similarly, right? So we need not show this step, directly move to this step. And 0 0 cancels, then 6 1s are 6, 0 0, then 2 3s are 6, 5s are 10, 0. So this will come out as 50 divided by 3 meter per second. So this is the final velocity of the car is given in the question. And question clearly is saying mass of the car is 1500 kg. So this is the mass of the car. Okay. With this we have to find the work to be done to increase its velocity from 30 to 60, or in other words 25 by 3 meter per second to a higher velocity, final 50 by 3. How much work needs to be done on the car, right? So for that, let us just start like this. So now I'll just write here initial kinetic energy, which is, let us say, E KI. Okay, so initial kinetic energy, because the car is moving, so we have to use the kinetic energy formula. It will be half mu square, because initial means we have to involve the initial velocity. So let's just simply do that. Simple case of half into mass of the car is 1500 kg into u is here, as you can see. We have to use the SI unit, so u square means 25 by 3 into 25 by 3 2 times. Then here square, so meter square. And here second to the power minus 1, so 1 2s are 2, so second to the power minus 2, because it is u square. Right, so that's our thing here. Now here 2 1s are 2, 7 is going, 1 in hand, 2 5s are 10, 0, 3 1s are 3, 3 2s are 6, 1 in hand, 3 5s are 15 and 0. So that much, I think. And so here 25 into 250 is 25 is 625, 1 0, so you can put there, and here multiply to 25. That will give you, forget about the 0 for time being, 5 5s are 25, 12, 31, 2 6 are 12. So here as you add 5 2 6 5 1, finally don't forget to put the 0. So when you multiply these three numbers, you're going to get 156,250 divided by here 3. Let's change it to energy, so to the SI unit, so kg. Here I'll write meter only once per second square. Means meter square means meter 2 times is there. 1 is written and 1 at the back you can write. I'll show you why. Okay, so here we'll see why. So that we can arrange it in the SI unit form to the common unit form, that is kg meter per second square we know is Newton, and here meter. That way we can change it simple to the simplest form of the SI unit for energy, which is Newton meter is written in the best unit. Newton meter is written in short form is joules, in honor of the scientist Joule, right? So let us just put this one okay there. Similarly, you can calculate the final kinetic energy. So you write here, and final kinetic energy, which is EKF. If we were to put, that will be half into, and final velocity v square. Initial is u and final is v. That's the only difference. So here half into m is 1500 kg, v is, as you can see here, 50 by 3 2 times. Right, so I might as well remove this step because you're not going to need anymore. So here v square means meter square for this meter square, and this is also square, so 1 2s are 2, second to the power minus 2. That way we can cancel this. 2 1s are 2, 7s are 14, 0. Okay, so 7 2s are 14, 1 in hand, 2 7s are 14, 1 in hand, 2 5s are 10, 0, 3 1s are 3, 3 2s are 6, 1 in hand, 3 5s are 50, 0. 5 5s are 25 and double 0 into 250. So just forget about these zeros. 250, sorry. 25 into 25 is 625. We know by memory also. 230. So when you multiply all this here, you're going to get this divided by 3, and here kg meter per second square, and meter square 1 gone here, 1 at the back we write to change it to this Newton meter form. So let us write down. So here 625,000 divided by 3 Newton kg meter per second square is written in honor of the scientist Newton. Meter, that is same thing. Then a simple SI unit of energy, we change Newton meter to the joule, right? Therefore, question go back. What is the work to be done to increase? So work done will obviously be final kinetic energy, EKF, minus initial kinetic energy. So final is here 625,000 by 3 joule minus initial is here, this one 156250 by 3 joules. So we write here 3 LCM, so 625000 minus 3 ones are 3, so 1 into 156250 is that number itself, and joule you can bring it out as a common factor. So it's just a matter of subtracting these numerator values, which we can get, I think, easily. So let us do that. 625000 and 052651 as we subtract minus and plus, so it's 0, 10 minus 5, 5, 9 minus 2, 7, 14 minus 6, 8, and then here 1 gone, so 11 minus 5, 6, and 5 minus 1, 4. So bigger plus, so the answer will be, work need to be done is 468750 divided by 3 joules, right? So I think this is cancelable. So 3 ones are 3, 3 ones are 3, 1 in hand, 3 fives are 15, 1 in hand, 18, 3 sixes are 18, 3 twos are 6, 7, 1 in hand, 15, 3 fives are 15, 0. So the work that needs to be done is 156250 joules. Okay, the first one. Let's go to the next question. So this is done. 3, okay. I'll go to question number 3. I think this is on page 163 if I'm not wrong. Yes, the blue letters there at the top left side of the page 163. 163, yes. The kinetic energy of an object of mass m. So here, m is the mass given in the question itself, mass of the object. Kinetic energy of a mass m, moving with velocity, so velocity is v, 5 meter per second, is 25 joule, means that is the kinetic energy. Ek is 25 joules. This is the kinetic energy. This is the velocity. This much is given. Let's do this first. Now since here Ek is given as 25 joules from the question itself, right? So that implies Ek formula there, half mv square. So let us replace that. Half m is m itself and v is here, so v square. That is Ek equal to 25 joules. Okay, so here, once we're through with that, next step here, as we do this, you're going to get here half m, nothing is done now, so v is here 5. So v square will be 5 into 5, and v square means here also meter square, and second to the power minus 1 will become second to the power minus 2. Because this whole thing is square, right? 5 v square means like this. So 5 into 5 meter square, and 1 2s are 2 minus 2 power. I hope that's clear. Is equal to here 25 joules. So with this we can see that we can find m. So don't move this m and shift the rest. 25 joules is there, just keep it, and then this m is here, so 5 up will come down, this also will come down, and meter square will come down, second to the power minus 2 will also come down, this much. So we may as well cancel this if you want. 5 5s are 25, and 5 and 5, so you're going to get 1 joule, 1 is left. Now joule we know can be changed into, we know that nothing is remains 1, so joule is Newton meter, right? We're going the reverse, okay, backwards. Meter square, here meter square, you can just write, just keep it like this. And we're changing this joule to Newton meter to match up with this, to cancel out whatever is possible, okay? So 1, and we know that Newton is, as we have done previously, kg meter per second square. The best unit of Newton is kg meter per second square. Then here 1 meter is there, so don't forget that, divided by, down here is meter square, and second to the power minus 2. So this second to the power minus 2 cancel. Then here meter 1 gone. So 2 minus 1 is still 1 is there. Then again 1 meter is gone here. I hope that's clear to you, right? So you're left with only 1 kg. So the mass of this object is 1 kg. So we found the mass. So here, page 163. Okay, so here, oh, we forgot to shift this 2, sorry. Here, 2 also has to go up. So you got here, sorry, 2 ones are 2 kg. Not 1 kg, but 2 kg. Slight correction, please do it. So the mass of the object we found out, this object is 2 kg, which was not known a moment ago, right? So go back to question, what will be its kinetic energy? So case 1. Question is saying, what will be its kinetic energy? Let us put here kinetic energy EK1, let us say. Okay, EK1. First case, so EK1. What will be its kinetic energy when its velocity? When its velocity, let us put the velocity as V1. Velocity is doubled. So this is the first question, case 1. So you can write like that also. So that is, in other words, this velocity is doubled means 2 times doubled, 2 into original velocity v. So we can write here 2 into 5 meter per second. So 2 5s are 10 meter per second. So if its velocity is 10 meter per second, which is doubled of the original, what will be its kinetic energy? So simple, you can write here, therefore its kinetic energy EK1 will be half mv, here doubled 1, we have to use v1 square. So half into 2 kg, because m is 2 kg, v1 is here 10, so 10 into 10 v square, v1 square, and meter square, and second to the power minus 2. So this 2 cancel means you're going to get here 10 tens are 100 kg. Just write only 1 meter per second square. So double meter square, 1 meter, and 1 at the back you write. We know now how you write 100 kg meter per second square is written in short as Newton, and here meter. So that is equal to 100. In short we write as joules. So the first kinetic energy when the velocity is double is 100 joules, right? Now that's your first answer. Case 2, let us go to case 2. Okay, we can just continue here. What will be its kinetic energy? Go back to question. When its velocity v2, let us write here ek2, and v2 is increased 3 times. Is this time it's not doubled, increased 3 times. So you write here increased 3 times. This is the second case, second question. So v2 is 3 times means instead of double 3, and this will be 3, and so 3 5s are will be 15. Up to here we write it. Then the rest, let's just do it right up to there. So therefore its kinetic energy in case 2, ek2, let us say. So you can see here half mass is same, the same object, v2 square. So half into 2 kg into v2 is 15, so 15 into 15 meter square, second to the power minus 2. So 2 cancel. 15 into 15 is 225 kg meter per second square into meter. So this will be 225. This one is Newton meter. So 225 joules. Right, so the second case, the kinetic energy will be 225 joules. Okay, we'll continue the next 2 questions in the next class. Okay, so let us continue in the next class.